All right, let's talk about that research study. So the research study that I'm actually going to talk about came out this past year in Journal of Medicine. So past year would be 2021. And it looked at the effects of slow breathing rates on HRV, heart rate variability, and arterial baroreflex sensitivity in essential hypertension. So if you're wondering what are all these words, well, slow breathing. So we're going to talk about a slow respiratory rate. We're going to talk about heart rate variability, which you probably already somewhat familiar with. And then arterial baroreflex sensitivity is probably something that you've either kind of heard in passing, or most of you probably have never heard of that. And I'll talk about that here in a second. And then essential hypertension. So what is essential hypertension? So essential hypertension is the most common form of hypertension. Hypertension is going to be high blood pressure. So when we experience kind of an influx of high levels of blood pressure against the arterial walls, that can actually cause a lot of damage to the epithelial walls or the epithelial cells that surround our blood vessels. And then also too, it can cause significant difficulties for the heart. The heart's having to work harder and to pump harder, or is pumping harder, resulting in blood pressure. Now, the baroreflex is actually a feedback loop that is there to help maintain homeostasis of blood pressure. When we have a baroreflex that is really sensitive, that means it responds almost either at control or to other variables or factors in the body to tell blood pressure to either regulate itself up or down. Because sometimes we need blood pressure to be regulated downward, and sometimes we need it to be regulated upward. And we actually know that one of the major influences of heart rate variability is indeed your baroreflex. So again, how does the baroreflex mechanism work? How does it help us to maintain appropriate blood pressure? Well, it's complex, but it's also not that complex. I'm going to tell you the less complex version of the baroreflex mechanism, but there's actually a lot more complexities that kind of run this. Again, it's a feedback loop system. And when I say a feedback loop system means that it comes full circle. It basically creates a 360. So we actually have in our carotid sinus and then in the aortic arch of the heart, we have these receptors, blood pressure receptors called baroreceptors. And the baroreceptors are there to kind of monitor to see whether or not there are significant changes in an upward direction of blood pressure or a decrease in blood pressure. So they're really there to kind of like monitor and kind of look out to see whether or not we need to regulate blood pressure upwards or downwards. So again, in the aortic arch of the heart, and then also in the carotid sinus. So these, again, blood pressure mechanisms are always kind of scanning the environment to determine which way are we going. When they detect kind of an increase in heart rate, so heart rate is increasing, and then therefore too the subsequent later on blood pressure increases, these baroreceptors say, okay, I sense now that there is indeed an increase in blood pressure, an increase in heart rate that are coinciding with one another. And then what it does is it actually sends a signal via the vagus and glossopharyngeal nerve, and then also through the use of a neurochemical neurotransmitter and neuromodulator called acetylcholine. It sends a direct signal back up into the brain, into the medulla, that actually indicates to the body blood pressure is going up, and now we need to down regulate it. And so this feedback loop system will actually send back down through the NTS of the brain, back down to the aortic arch and baroreceptors of the heart to then say, okay, we need to calm down. So the vagus nerve will actually help to release or reduce blood pressure via these baroreceptors. The exact opposite can happen as well. Acetylcholine is really interesting because it can actually work as what we call almost like an upper as far as neurotransmitters goes. So basically it can cause almost like a stimulant type of effect, which can increase heart rate, increase blood pressure, but it also can result in a reduction, so it can actually decrease heart rate, can decrease blood pressure as well. So it works as a really cool neurotransmitter, and it's a part of this feedback loop system. So when someone has a sensitive baroreflex, that means that it actually is very sensitive to the messaging that need be to help create homeostatic blood pressure. And that can be good, it is good because it can help again to regulate blood pressure. But when the baroreflex mechanism is not very sensitive, sensitive and blood pressure is high and there's no means to help down regulate it, then that's where we can have some problems, and it can lead to some significant difficulties, especially when it comes to essential hypertension. So essential hypertension, primary hypertension, means that there's no other physiological cause or mechanism that we can identify that is resulting then in hypertension or resulting in high blood pressure. And we know that people with really high blood pressure, or even if they're approaching high blood pressure, can have a baroreflex mechanism that is not very sensitive. In other words, it doesn't really listen. So how do we actually engage it? Can we make it listen to us? Well, we know from research and science that there's a lot of different mechanisms to help out with that. We know exercise is really a key component to helping with approximate and to alleviate the difficulties of high blood pressure that it can cause. And one of the things that we know too is that it's a silent killer. Like, most people don't feel high blood pressure. Like, if it's really, really high, maybe you'll feel it. If it's really, really low, maybe you'll feel it. And when people get into that 140/90, which is actually changed to 130/80, when they get into that range, most people are not going to be able to sense that or to feel that. Like, our level of internal bodily awareness or interoception typically isn't strong enough, or maybe I would say sensitive enough, to feel changes like that. So that's why we have to be very careful and monitor those things. That's why you get checked up on this when you go to see your physician each time that you go. So it's one thing that to just kind of keep in mind. If you're not checking that, check it. It's a very, very important biomarker or biometric, as important, if not more important, than heart rate variability. And I'm an HRV guy. So back.